Hello! So, today we are going forward for the second chapter of the guide. This is a quite substantial chapter, so I'm going to divide it in two, and so we are going to have 2.1 today and 2.2 next time. So, to continue on the guide, we can just click on Introduction to Modifiers, and we see the chapter. I would really suggest you to read it, especially the first part, because took a long time to find, the perfect way to word it. But let's see what I can do while repeating it in video format. So, the main concept of programming in an object-oriented language is that you just have objects. And when you have an object, you can call some methods on it. And the method will give you a result. And this result, it's another object. And the only thing you can do with it is that you can call a method on it. And it's going to give you a result. And that's it. And you never exit from objects. The best thing you can do is that you call another method and you get another object. And how do you look at this object? Well, you call another method on it. And so, in order to understand what happened when you call those methods, it's important to understand which are all the objects that can possibly play a role into this method execution. And so you get to the concept of reachable object graph. So the reachable object graph is a set of all the objects that somehow can be reached starting from a specific object. And this is a very important abstraction to keep in mind, because whenever you are calling a method on an object, in some sense, the whole reachable object graph can be cooperating in order to reach your result. So when you want to be able to predict what is going on, you need to have an understanding of what is going to happen on all the objects in the reachable object graph. In particular, you can say that an object is mutated if any object in its reachable object graph have changed in some way. So, if you want to think about it as fields, you can say that an object is mutated if a field in the whole reachable object graph of that object is updated. And so we have two concepts here. We have field update, and field update is done on fields, not on objects. And then you have object mutation, and the object mutation is on the object, is not on the field. So you never mutate a field, you mutate an object. You update a field, you mutate an object. Terminology is important because it lets us talk. It's a way for us to communicate. You can say that an object is mutable if there is any way at all to mutate this object. And so, on the opposite, an object is immutable if there is no way any user code at all, even if it's trying to play a little bit dirty, no code at all can mutate it. Where mutating it means doing a field update in the whole reachable object graph. Now, English is not the best language to talk about mutable and immutable, because those two words tend to sort of sound like the same. They both sound like mutable. And so I will try to stress as much as I can, mutable, immutable. In 42, you have a type system that helps you to check if something is mutable or immutable. And this is different from what happens in other languages, where the poor programmer with their, finite size brain have to somehow keep track of the mutation of all of the objects. Here, the type system can do this for you in a very flexible way. For example, we have seen the class point the other time, And the class point has only number fields, and there is no way to update those fields, so all the instances of point are immutable. And the decorator data can recognize that, and so when we create a point, we directly get an immutable object out, a non-mutable, an immutable object for any time we create a point. On the other side, here we try to create the class animal with the purpose of making it mutable so that it can change. And so we use data and we declare a single field here in line 2, var point location. And this var keyword is the first time we see it, and it's a keyword that represents a field that can be updated. And so a method that can update that field, it's a mute method, a method that can mutate the object. In particular, the modifier that is, the topic of the lecture here today, it's a keyword that we put either in front of the method or in front of types, and it identifies the type of the reference to something, So here, this is a method with no explicit argument. So this method takes exactly one argument, the argument number 0, the receiver, this. And so the this argument, it's going to be a mute animal. And so here in this code, we see two new keywords, var, to introduce an updatable field, and mute, to talk about mutable types. And to make our animal run, so that, for example, they can jump forward 20 units, we can do this dot location, open round, and pass the new value of the location. So this method, this dot location of that, is the setter. So this let us set the new value. So this dot location of slash location, the receiver here is this. So this is equivalent to this dot location open close. Dot add x equal 20 num. So here we are adding 20 to the x coordinate, creating this new point, and use it to set the new location. So this method, when it's called, will make our animal jump 20 units forward in the x coordinate. And if you want, you can have a little snippet of code that declare a mute animal dog equal animal location equal x equals 0, y equals 0, and this of course is going to be a point because the animal take a point in the factory. And data have recognized that the animal class accepts for mutable objects. Some instances of animal are mutable. So we can manually write mute animal, or absolutely the same as we show the line after, we can just write the name and L42 is going to infer mute animal here in line 2. Then I can, for both dog1 or dog2, just call .run because the variable is mutable. Now, if I were to write im here, or im animal, or animal, and those three variations will be, exactly the same, I will make dog2 an immutable animal. And so this animal will not be able to move to another location in space. And so the code in line 3 will be ill-typed. The compiler will give you a type error there. So we have seen a very simple example, this mute animal with a single updatable field, immutable point. What if we make it a little bit more deep, so that, for example, our animal have two fields, an updatable point location, but also a mute points path. Remember, points is just the list of points, and here I'm writing mute points path. Notice that I'm not writing var points path. I'm writing mute point path. I could also write var mute points path. So let's see what is the meaning of those options. If I write points path, I mean that there is an immutable list of points. So the points that are in that list will be always the same, and that list also will never change. If I write var points, then it's going to be an updatable field to immutable list of points. So I have this list. I don't know, let me take an object. Here I have this list, and this list is immutable, so I cannot change what is contained into this list. But since it's var, I can replace the list with another one that maybe have a different set of elements. On the other side, if I declare a mute points path, it means that the list is mutable. So I can attach and remove elements from the list by mutating the list. But the list is superglued to the hand. So there is no way I can change the list itself with another one. In concrete, this means that there is no setter. If I want the setter, I write var. If I don't write var, I don't get the setter. Now, here we have a method move that instead of making our animal jump forward, it makes our animal follow the path of point. So we have two lines here in line 6 and 7. This dot location equals /path dot left. This is producing the leftmost point on our list of points and setting it into the current location. And then we want to consume this element from the list. And so we want to remove the leftmost element from the list. And how do we do it? This dot, hash path? Why there is a hash here? You know, I would expect all of you will have just guessed that we will have been writing something like dot path. Instead, in 42, we have to write hash path. And the point is that dot path is the getter. And what's the use of the getter? It's giving you the value so that you can read it. You can know what this value is and you can examine it. This variation with a hash is called the exposer. And you call the exposer to give to the user not just the read-only version of the data, but the mutable permissions over the data. So by calling hash path, we get the permission to mutate this data. So if you define a field as mute, you get the exposer, this method that looks like a getter, but it's more dangerous in some sense, as we will see. It's more subtle. It lets you mutate the object and not just get it to read it. And again, in every other language, these distinctions don't exist. And the getter and the exposers are, merged together in the same concept. And this means that the programmers, with their little finite brain that is not even the size of Jupiter, they have to constantly worry about what is the meaning of that getter. Is it just giving the read-only permission, or is it giving the write permission? So in 42 you have the syntactic distinction. So hash path is explicitly giving the write permission, and this symbol that is strange to see and a little bit confusing at start, actually serve exactly the purpose of making you a little bit worried about what you are doing, because maybe you should have just given the read permission. Now here, of course, it's perfectly fine. We are inside of the animal object, so the animal object can access in write permission its own objects and call remove left, and this of course is gonna be safe and is not going to cause any problem. Ta-na-na-na. So if there is one thing that I've learned in this last 20 years that I've spent like all of my waking hour trying to become the best programmers possible, is that when something looks simple and reasonable in programming, it's near always just wrong. And the more it's working on the small examples, the more it's going to hurt you when you try a big, more involved example with more moving parts. So here, if you make a simplish example, or if you want to say an example that respects how do you expect to use this code, the code above will be reasonably predictable. We have here a 0 with a point in 0, 0, a PS1 and a PS2 with points 12, 20 and 1, 2, and then you have PS2 with points 0 and 1, 2. And then we have two animals. We have dog 1 and dog 2. They both start with location 0, and they have path PS1, and the second dog has path PS2. And then I do dog1.move, and then I do dog2.move. And what's happening here? Well, the first dog will go from 0, 0 to 12, 20. And the second dog will go from 0, 0 to 1, 2. Reasonable. We are following the path that we have given the dogs. Now, what happens if I change the example a little bit? Here we still have 0 in 0, 0. We have PS, a list of points, in 12, 20 and 1, 2. And then we have two dogs, but only one list of points. And so both dogs will share the same list of points. So dog 1 is in location 0 and path PS, and dog 2 in location 0 and path PS. And then we move both dogs. Well, the first dog still works perfectly fine. The first dog will look to the list. We'll see that is starting with 1220. This is the left. It will take 1220. It will put it in location. And then it will remove the leftmost element from the list. And so the list is going to just be 1 and 2. Now the second dog actually sees the list of the first dog. And so the second dog will actually move from 0, 0 to 1, 2, and then it will remove this element from the list, and so the list will be now empty. And this is probably not what you expected. At least when we wrote the class, we expected that the list was somehow owned by the dog, that another dog could not consume some points randomly. But why PS is giving us trouble because it's shared, but 0 is not giving us trouble even if it's shared? The issue is that 0 is immutable. So it doesn't really matter if you share the same reference to the unique number 0 that lives in the mathematical world, because you can't impact the concept of 0. So having in the reachable object graph an immutable object, it's not a big deal. You can have as many immutable objects in your reachable object graph, and you can still just reason about your reachable object graph alone. But if you have mutable objects in your reachable object graph, then just doing modular reasoning on your own reachable object graph is not enough. You need to somehow do a complex global reasoning over all the objects that share the same mutable objects in their reachable object graph. So again, let me take up some friends to make this example a little bit better. As you can see, here we have two objects, and they both have a logo. Here you see the logo, and here this one has it on the legs. Here you see the logo. And those two logos are the same logo. You can say that both of them have the Autobot logo. Now, do they have the same Autobot logo, or do they have different Autobot logos that just so happen to look identical? Doesn't really matter, you know. You want to say that they just have the Autobot logo because we are thinking about this object as an abstract concept, and so they should have a field that contain an immutable reference to the output logo. Now let's consider a gun. This gun, you can say that one of the two robots have the gun. The other one doesn't have the gun. If the other one have to take the gun, you will imagine that you take the gun off from the first robot and then you give it to the second one. And now this one has the gun, but this one does not. Sadly, stuff can go wrong, and this gun has more than one 5mm port. So if you want to try something strange, you may end up in a situation in which two different robots are sharing the same gun. And you can tell that they are going to have a very, very hard time aiming, right? So how can we be sure that certain objects are not shared? The solution in 42 is to use capsule fields. So in 42, you can define a field capsule instead of mute, and this will be a mutable field in the sense that it points to an object that can be mutated, but it's going to be encapsulated. And this encapsulation comes in two parts. First, when you create the object, so the factory generated by data will require a capsule points. And so the capsule modifier will propagate these guarantees outside of the factory and will make sure that at the moment of the object construction, the list of points is under the control. For the a metaphor of the gun is like saying that the gun came straight out of the factory, for example, like the actual machinery that produced the gun, and the robot takes it directly from the factory, so that there is no way another robot could be already handling it, And then we have a second feature for capsule fields. That is, we cannot accidentally give away access to our object. So the capsule field cooperates with data to make sure that there is no way another object can sneak from the back and somehow manage to attach to the same gun. Especially, they will not be able to attach to the same gun in a mute way. They will not both have a mutable right to access on the same gun. And this is done through an indirection, because in programming, an extra layer of indirection is usually the best tool to solve a problem. And so here we have our move method that is very similar to what we've seen at the start. So this dot location is /path.left, because /path gives us the read-only access to the list of points. So no problem there, no risk of leaking a mutable reference, because we just ask for the read-only permission. But then here we call an auxiliary method, this dot remove left path. And we define a method called remove left path, but they look sort of different. You see, there is a little bit of a mismatch. Here we are calling the method of immutable this receiver, but this method is a class method. So it should be called on the class object, not on a mute object. And this method takes no argument, but this method is declared taking a mute points path. That looks a lot like our field. So why the field have become a parameter? And strangest of all, there is this very mysterious annotation at cache.clear that seems to say that we are doing some kind of caching. And indeed, this way of working with the capsule fields is strongly connected with caching, as we will see in chapter 6. So for now, you just have to know that the method annotated with cache clear is called a capsule mutator. And the idea is that data is doing a intermediary work to guarantee that if you follow the specific pattern the data knows of, you cannot leak the mute permission to points. So data wants us to declare a method that have an extra parameter that looks like our field, and it's a class method. And then data uses this method to generate a mute method that take a mute parameter and doesn't have this first argument. In this way, the capsule mutator can simply do path.removeLeft. We have removed all the uses of the hash, and so it's pretty clear that we are not leaking the mute permission outside in any way. And now our objects are guaranteed disjoint, because the reachable object graph of animal only have mutable objects inside of those capsule protection. So in particular, I'm talking about various kind of mutable objects, and this really helps me to reason. So we have immutable objects, objects that you cannot mutate, and they are very easy to use, they're very easy to reason about them, but for certain kind of domains, you really want an object that can change over time. And so you can have a shallow mutable object. A shallow mutable object is an object where all the fields are immutable. They can be var, so you can update the value of the field with another object, but the object itself cannot be mutated. And then you have deeply mutable objects, like the animal that I shown before, a mutable object with mutable fields. And those are useful sometime, they have their own use cases, but they are very dangerous, as I've shown you in this lecture. They are, it's easy to make mistakes when you use them. And it's very hard for the programmer of those classes to prevent the user from doing those mistakes. And then, as a point in the middle, as safe as the shallow mutable objects, but a little bit harder to code with, you have those objects with the encapsulated state, where all the mutable reachable object graph is actually protected under capsules. And so if we were to rewrite the example of before, we can have a 0 in point in 0, 0, and then we will have to write capsule points PS equal points of 12, 20, and 1, 2, and we have to write capsules so that when we create our dog1, we can pass location equal 0, no problem, because it's immutable, and path equal PS. That is our capsule points. And so the type system will be happy to accept this line, but this line number 4, that will create the same problem that we have discussed last time, where we will have our animal in location 0 and path PS, well, this will not compile. You will get the error that the capsule PS have already been used one time. And so the type system is checking that any local binding declared capsule can only be used 0 or 1 time. And in this way, the type system can keep track that the object is still free to be used, is still not engaged in any permanent mixture, permanent aliasing relation with other objects. So this will not work. So what can we do to create another dog? Well, we can make an animal in location 0, and the path, we can write it in place. We can declare another capsule local variable, or we can just write it in place. And the type system is good enough to understand what we are trying to achieve. So we get path, that is a list of points, so I can just write slash with 12, 20, and 1, 2. So as you can see, this list looks like this list in the sense that it's structurally equivalent, but they are now two different mutable objects that can be used independently by those two animals. So for today I will stop here, and next time we will see 4, 5, and 5 and conclusions. So see you at the next one. You are still here? Well, thank you for hanging out so long. So what can I do for you? Well, I can try to make something for the thumbnail. Let's see how it works. So what can be like good face for this thing? Like I don't know. Don't know. What can be a good face? Something like this. Yeah, maybe something like this. Could be like leave my gun. I could put a title. Leave my gun. That will be the title of the video. Yes. Okay. Bye bye the real this time.